The vast majority of the deep seafloor is unseen and completely remote from human experience, but it's not immune to the impacts of human activities. Around the world, coastal and international cargo ships make hundreds of thousands of trips annually. Each ship may transport thousands of standard shipping containers, resulting in hundreds of millions of container trips per year. These numbers are only growing with increased global population. Most of this cargo arrives at its destination safely as scheduled. However, the routes traveled by cargo ships can be treacherous, and container loss is difficult to prevent. It's estimated that thousands of containers are lost each year as they are transported along international shipping routes. While this is a small percentage of the containers being transported, the impact on the health of our ocean is uncertain. During a remotely operated vehicle dive in June 2004, MBARI scientists came upon one of these lost containers. The tracking information printed on the container was used to determine that it was lost just 4 months prior from the cargo vessel Med Taipei. Because the container was found within the boundaries of Monterey Bay National Marine Sanctuary, there was particular interest in determining the circumstances of its loss. The Med Taipei, sailing from the port of Oakland, reported that 15 containers were lost within the sanctuary boundaries during a strong winter storm, and another 9 were lost before reaching port in Long Beach. Coming across a shipping container in the deep sea is akin to finding a needle in a haystack. A partnership between MBARI and the Monterey Bay National Marine Sanctuary has taken advantage of this unique opportunity to learn more about the presumed effects of a single container on deep sea ecosystems. Scientists returned to the site 7 years later to investigate the communities of animals on and around the container. The seafloor near the found shipping container is dominated by relatively long-lived soft corals, sea pens, sea whips, and anemones, and a sea cucumber called the sea pig. However, the container was found to be well colonized by animals typically found on rock outcrops in the region, as if it were an island of hard substrate in a sea of soft sediment. The most abundant animals on the container were tube-building worms. Numerous young scallops were also present. The container seemed to provide a useful hard surface for a marine snail to lay its egg cases on. While all of these animals are found on hard surfaces in nearby areas, the abundance and diversity of animal species on the container, and the seafloor up to 10 meters away, was lower than that typically encountered in the area. This reduced biodiversity may be due in part to the absence of some animals found in rocky habitats in the region, including long-lived sponges, corals, and feather stars, none of which were observed during our survey of the container. The absence of sponges and corals suggests that either 7 years is a relatively short time frame for colonization by some deep-sea animals, or the potential toxicity of the container's zinc-based paint could deter more sensitive animals from settling on its surface. We're just beginning to look into the potential toxicity associated with this container. The lower number of animals close to the container may be related to several processes, including changes in near-bottom currents around the container, its role as a refuge for some species, and changes in the influence of predators and scavengers near the container. The presence of lost shipping containers on deep seafloor ecosystems is a consequence of human activities that is rarely seen or even considered. This study sheds light on the importance of basic research to understand the structure and function of deep-sea habitats. Long-term views of natural deep-sea ecosystems can help us better understand the impacts of human influence on the deep seafloor. This is Josie Taylor at the Monterey Bay Aquarium Research Institute.